Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will continue our discussion on inverse Fourier transform, where I will show you the solution to another sample problem. Okay, problem number 2, where again you are given a signal shown in this graph, and you are asked to determine the inverse Fourier transform of this signal. Okay, so the general formula for the inverse Fourier transform is x of t equals to 1 over 2 pi integration from minus infinity to infinity for x omega e j omega t d omega. Okay, and if we look at our signal here, okay, we have, if we determine the mathematical equation for this signal, we will get x omega equals to, it is cos omega at omega in between minus pi over 2 to pi over 2. Okay, and it is 0 elsewhere. Okay, so if we substitute this definition of the signal into this general equation, we will get x of t equals to 1 over 2 pi integration from minus pi over 2 to until pi over 2 for cos omega e j omega t d omega. Okay, so the rest is 0, so we just leave it, okay, like this. Now, the most important part is the integration of this. Now, this we have two terms, which is cos omega in and e j omega t. Okay, so as I have explained in the previous video, okay, on sample problem number 1, what we can do is we can apply the integration by part. Okay, where the general equation is uv minus integration of v du. Okay, now you have two terms, okay, cos omega and ej omega t. So you can choose either one, okay, to be u and dv. So let me just draw a line here. Okay, so first you want to choose what is u, and you want to choose what is dv. Okay, so this u will be differentiated, okay, and this dv will be integrated, so you can get v, while this u you need to differentiate, so you will get du. So the idea is to choose between cos omega and e j omega t, the one that will be easier to differentiate, okay, as u, and to choose between these two, the one that is easier to integrate, as to choose, okay, between these two to be dv, the one that is easier to integrate. So let's say in this case I choose e j omega t as u, and I choose cos omega as dv, okay, because if I integrate this, I will directly get sine. Otherwise, if I choose this as dv, if I integrate, I will get e j omega t over jt, which is a bit complicated. So let's say we choose this as u, so then du will be jt e j omega t. This one cos d omega, okay, So what you need to do is you integrate this, so you will get v, which is in this case will become sine omega. Okay, so next you multiply this and then put it into this equation. Okay, so you will have u is uv. So let's put the sign first. Okay, sine omega e j omega t minus integration of this one. Oh yeah, this is correct. Okay, and then this one is sine omega, and du is jt e j omega t d omega. Okay, because we need integration. Okay, so if we rearrange, we will get sine omega e j omega t minus this jt is constant, so let's put it at the front, jt. So here we will left with sine omega e j omega t d omega. Okay, so again I want this part to be integrated using the integration by part. Okay, but this time I will choose u e j omega t, and my dv will be sine omega. Okay, so this one, if I differentiate again, I will get jt e j omega t, and this one d omega. If I integrate, I will get v minus cos omega. Okay, so let's put this inside here. So if you rewrite, we will get sine omega e j omega t minus jt. This will be this one multiplied by this, you will get minus cos omega e j omega t. Okay, which is this uv multiply minus integration of v. V is minus cos, right? Cos omega and again jt e j omega t dt. Okay, so now you see the pattern. Here we come back to similar to the original here. Okay, so since we have cos, okay, integration of cos is sine, and then integration of sine, you get cos again. So this is actually if you continue, it will never end. So what you can do is, okay, do like this. Okay, so initially, okay, what we integrate is cos omega e j omega t d omega, right? And this is what we get. Okay, so you write all this equation, you get sine omega e j omega t. Okay, this one after you do the integration by part, okay, in the previous slide, and you will get here plus jt cos omega e j omega t, again plus t square. Here you will get cos omega ej omega t d omega. Okay. Now, if you see, we have here cos omega, this part, cos omega ej j omega t, and you also have here cos omega ej omega t d omega. So let's bring this here. So you will get t square, and this one will become minus, yeah, minus t square integration cos omega ej omega t d omega plus this one, okay, cos omega e j omega t d omega equals to sine j omega t plus jt cos omega e t. Okay, and this one, if we simplify, we can get 1 minus t square integration of cos omega e j omega t d omega. Okay, just write back this. Omega t. Okay, so which means the integration for cos omega e j omega t d omega is equals to, if I bring the common terms outside, it will be e j omega t over 1 minus t square multiply with, here we have sine omega plus jt cos omega. Okay. Okay, and if you remember the okay, in the previous slide, we said that the general formula for the inverse Fourier transform is 1 over 2 pi integration from minus pi over 2 to pi over 2 cos omega e j omega t d omega. Okay, so you replace this cos omega e j omega with this. Okay, so you will get x of t equals to 1 over 2 pi, okay, multiply with e j omega t over 1 minus t square sine omega plus jt cos omega, this one integration from minus pi over 2 until pi over 2. Okay, so next step is for you to replace, okay, omega with pi over 2 and minus pi over 2. So if you do that, you will get x of t equals to 1 over pi 1 minus t square cos pi t over 2. Okay, so this is the equation for the signal in time domain. Okay, this is the inverse Fourier transform of the given signal.